All right, so good morning, good evening, good afternoon, and welcome. So this is lesson 8.5. We're going to be learning about the distributive property and starting our factoring part. Now, we had talked a little bit about distributing property in lesson 8.3 when we started multiplying some things out, but we were multiplying out binomials together, where the two figures, and I would show you guys multiple ways of doing it. Now we're going to talk about factoring them out. Okay, homework is on ALEKS. Here's your essential question. If you do not have the notes, please go onto Canvas and download them and print them out. Or you can handwrite them on a separate piece of paper if you want. Don't forget, ALEKS is up and running. I need you to have your 4 topics done by Sunday. Okay, so anything above 4 is extra credit. So at the end of the year here, or even at the end of this quarter before spring break, when you say to me, hey, what can I do to get my grade up? That's going to be the only thing I'm going to tell you to do. All right, so let's get started. So very first thing is we have bell work. We did it on quizzes, so I wanted to make sure everybody understood that, but we're not going to do it on this slide. So we're going to talk about the distributive property in factoring polynomials. Okay, a big thing involved with that when we do this factoring is kind of we need to start. If you guys could pause the video for a second and go get your books. Okay, it's very important for you guys to kind of look and see. We're going to start on page 520 about how they talk about the greatest common factor, okay, in relation to this. So how you start by factoring is we are going to actually factor out terms from here. Okay, so we got to find what is the greatest common factor. And some of you, this should be easy for, but some of you won't. So one big thing that happens is you guys remember your factor trees, right? So on a factor tree, you're going to try to find the lowest amount of multiplication. So it's going to be either 2, it can be 1, but it's not 1, a positive 1, it'll be a negative 1. It'll be negative 1, 2, 3, 4, 5. Those are the factors that we'll have. So what you would want to do is find out what's the tree on this one. So this one here, if you split it, would be 3 and this would be 3 times 5, right? That's the lowest factor, and then we have an x. And then what's happening is on this monomial, okay, we split 25, and their factors would be 5 times 5. And then we have 2 x's. So here's what the question is. The question is what do these two things share in common? Okay, what do they share in common that you can factor out? Okay, and then so what happens with this is we have to ask, what do these two share? So they both share a 5. Okay, so what I want you to start out is circle a 5. So that way you know that they share those two. And then they do share at least 1x. And do they share anything else? The answer would be no, because there's a 3 in this monomial, but there's no 3 here, and so that's it. So what we do then is you take what they share together in, well, I'm writing it in blue, but you take what they share together and you would factor it out. And so what we're going to do is we're going to leave right down here what's left behind. And so what is left behind on this? The only thing that's left behind is a 3. Okay, and then the only thing that's left behind on here is a 5. So it's plus 5x. And so how it works is you'd have to ask yourself, the main principle behind this is asking yourself, if I were to multiply this out, a monomial by a binomial, like what we've been doing, what would you actually do? So here, if I were to multiply this out, okay, you would get 15x, right? And then you would get plus 25x squared. So if you know, because 5 times 5, and then there's 2 x's. So did we factor this out to get to the same thing we have here? The answer would be yes. So for today, your answer, okay, is going to be this piece right here. So what I want to make sure is you guys understand that this is what we're going for today. You're trying to find out what the greatest common factors are, and you're factoring them out, putting it on the outside now, and then you're leaving what's left behind. So let's try again on this one. So this one's more complicated. So some of you are going to have to use the factor tree, the old school thing that you guys did in elementary school or in middle school when you guys started doing it. If you don't have this written down, you're going to have to back it up a little bit because I'm going to erase it. I need a little bit more room. Number 12, factor tree would be 2, 6. Right, and then you can go 2 and 3, and then that would be pretty much it. Now, if we do let's do 24. If I do 24, I would get 2 and 12, then it'd be 2 and 6, and then it would be 2 and 3. And then if I do 30, Okay, if I do 30, I will do 30 down here. If I do 30 here, I could go 2 again, and if I do 2, this is 15, and then this would turn into a 3 and a 5, right? So there's all your factors out. And you're looking at these terms here, okay, and we're looking at these terms there. So you guys get the gist, right? So one big thing is make sure that as you go through that you look at this and make sure how you get this factoring done the first time, okay? And then what you're going to do is we're going to look at these variables. And so on this one right here, we have an x and a y, and it's going to be plus, we have x, we have a couple y's, right? So you guys get the understanding. So what we're doing is we're actually going to be taking and we're going to be figuring out what actually shares alike. Oops. Cancel. Go. Close that. Yes. Okay. So what we're going to do, thank you, ma'am. Yes. What we're going to be doing is we're going to be actually taking this information out and we're going to write it over here. So what we have is we have 2, 2, and a 3. So 12 is 2 times 3, and then we have an x and a y, okay? You guys see that? We took these pieces here, we put them over there. And it's going to be plus, and then I did that in blue, so let me go back to blue. It's going to be 2, a 2, another 2, and a 3, right? So I know that those are the 3. And then I got an x, and I have 2 y's, right? And then, ladies and gentlemen, my last piece, I put it in red. So let me change through 30 to red. It's minus, and I got a 2, 3, 5, and then I have 2 x's and 4 y's. Woo, I fit it. Okay, so now that's basically this factoring all the way out. Okay, so what we're doing is we're taking everything that was small and we're expanding it out to what we have. So now what you have to do is ask yourself, okay, which one of these shares the same similarities, okay? What's the same properties? So for example, always try to start with the first one because once one of these is gone, you're not going to have a greatest common factor anymore, okay? What do they share? So they all share a 2. You can see that. They all share at least, so if I go a 2 again, this one shares a 2, this one's a 2, but there's no 2 here, so we can't share another 2. If I go 3, there's a 3 here, a 3 here, and a 3 here. If I do an x, I do have 1 here, have 1 here, and I have 1 there. And then a y, I do have a y here, here, and here. Okay, so on this first monomial, we're done. There's nothing else you can factor. It doesn't matter if this has a y and this has a y. This one doesn't have any extra. So it's what can you factor and rip out. So what we can rip out is 2 times 3, okay, which would be 6, and then we have an x and a y. So that's our factoring. So now we're going to close the bracket. So now you need to go by terms. So on our first term here, we have just the number 2 left, 2 plus. And then if you go to your second term here, we have 2 times 2, which is 4, and we have a y left. And then it's going to be minus, and you find your last piece, it's going to be, we have a 5, 1x, and 3 y's. And ladies and gentlemen, that's it. So what you're doing is you're factoring things out, and this is your answer. Now you can double check your answer, okay, by multiplying everything back in. So if I were to multiply everything back in to double check my work on this particular equation, it'd be 6 times 2, right, which would be 12xy. And then if I multiply this, it would be plus 24, 1x, and 2 y's. And then if I did minus, that would be 30. And then I have 2 x's, and I have 4 y's. So ladies and gentlemen, am I back to where I was up here? Yes, I am. So that's what you got to do sometimes also is double check your work to make sure if you're factoring something out, you need to distribute it again and make sure that you're doing your math correct. Okay, so that's the main focus for right now. Find the greatest common factor, and we're going to rip variables and numbers out that are shared in common. Work on these two yourself. All right, hopefully you paused the video and did it. This would be factoring out 3 times 5, w minus 3v. So what do they share in common? The only thing they share in common on this one is a 3 into 3. So you factor that out, and what's left behind is 5w minus v. Please don't forget the v. I saw a lot of students in class forgetting that one. This one here, there's a 7. Can we break this down to 7 and 3? Yeah, you can. Okay, but the question is what variable is here? The only thing in here is actually a -1. So, ladies and gentlemen, there's a 7 and 7, but there's no 7 here, so we're actually not going to factor out any numbers at all. Okay, so on this one, no numbers. But in fact, what it's going to be is it's going to be just variables. U, T, 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 so we know we're factoring out a U and a T. So if we factor out a U and a T here, we're taking one away, so what's left behind is 7 UTs, because if I multiply these back in, it'd be U squared, T squared. All right, so this is why when we're learning everything, it's a build-up process. When we started the exponents part and adding and subtracting the exponents, we did that lessons to understand you guys how these exponent properties work. On the quiz, that's why I wanted to make sure you guys knew how to multiply them in, so that once you multiply them in, you could also factor them out. So I took away the 1U, but I still have 1T left behind. And then this last one here would be what? Still a minus, but remember what's here but it's not written, -1, because UT times a -1 is in fact UT. So that's how you could double check your work as you go along. Think about, in your mind, mental math, how would you multiply this in if you were to write it out like that? Okay, so now here is a story problem, a word problem that just talks about a football is kicked in the air at the height. After so many seconds, it's modeled by this expression. So what I want you to do is, if you were to be presented with this problem, I want you to factor out I want you to factor out the equation first, and then you would plug in 0.3 seconds for x to see what your answer would be, right? So on this particular one, what's the greatest number that they share? Well, it's obvious that it should be staring you right in the face that they share 16. And they also share at least 1x. So if you were to factor that out, you still have a negative here, but I factored out the 16, I factored out one of the x's, but I left an x behind, and it's going to be +1. So there's your factored out answer, okay? And then what you would do is you would add in or substitute 0.3 into the equation. So here's the factored out example that the book has. So you factor out the 16. Now this part here, the only disagreement I have is because they factored out the -1 and they left x as negative. That would not be correct, okay? We wouldn't actually do that. I wouldn't want you to factor out and change the signs because most of you would probably not get it right, okay? And as a matter of fact, this would be negative and that would be plus, because that really doesn't matter how it works. As long as there's a negative on one side and a positive on the other, it doesn't really matter which one's negative and positive. The biggest key factor is that when you were to substitute, you would end up with 3.36. You just put that in a calculator, you go from there. All right, so what I want you guys to do now, please, is to factor out this word problem right here. All right, hopefully you guys did pause the video. Try it on your own, please, because the biggest key for you guys is to try these on your own. What is the greatest common factor you can yank out of here? So let's talk about it real quick, doing our factor tree. This would be 2 and 12. This would then be 2 and 6. This would then be 2 and 3. On 16, okay, if I did 16, 16 would be 2 and 8. That would be 2 and 4, and finally 2 and 2. So what is the greatest common factor that they share? Okay, and this example here, they both share this 2, and they share this 2. And then after that, it's a 3 and a 2, so they don't share. 2 times 2 times 2 is actually 8. So we can factor out an 8 from here. And we can also factor out the letter T. So if we factor those two things out, what's left here? Well, technically speaking, 8 divided into 24 would get you the number 3. 8 times 3 is 24, and it's minus. If I factor an 8 out of 16, what number times 8 equals 16? Ladies and gentlemen, that would be 2. 2 times 8 is 16, and you have 1t left behind. So here's your answer, okay? Same thing applies as before. what you would do is you want to know the height after 1 second. Okay, so if I wanted to, so here's my equation, that's the answer. If I want to know after 1 second, I would just put 8 times 1, and then 3 minus 2 times 1, like this, right? A little tiny bracket. And so this would be 3 minus 2, 3 minus 2, which is 1. 8 times 1 equals 8. So the answer to this is after 1 second, a kangaroo would be 8 inches off the ground. Pretty cool. Okay, so there are models that do this kind of stuff. Okay, that is one way that you guys could actually model something if you were to start to move on beyond high school, and if you were being a scientist like this, and you could actually create a calculation like this, then you could go around and create a chart, and you could create a chart of statistics, just like we do now for like when you guys are first born. There's a chart saying how big you should be for how long you are when you're a little baby. It'd be the same kind of chart, okay, where you would have an equation set up, and you could go around testing out kangaroos and saying, all right, they should be jumping this high, and if they're not, there might be something going on with them. So that'd be kind of cool. All right, so now what we're going to be talking about is factoring by grouping, okay? We had, if you guys remember, factoring by grouping is, if you guys go back to lesson 8.3 when we started multiplying, we would come up with, I would present to you guys equations like this, okay? So you'd be presented with this, and I told you guys to use either the box method, right, to solve it. You'd go 8 and 2, or x and 2 and x and 7, okay, or you would use the FOIL method, where you guys would do this, okay, and then you would multiply here like that. What we're going to do now is, some of you though did use the distribution method, and if you remember, the distribution method was to take this first piece, okay, and you would split it in 2. Whoops, let me write that arrow correctly. Okay, you would split it into 2. And so what you would do is you would take this first one, you'd go x, and then you would go plus 2, right? Hopefully you guys remember this. Some of you did this. And then you would take this last term, and you went x plus 7, and then you would go x plus 7, right? And then what you would do is you would distribute. So for in this example here, it would be x squared plus 7x, and then it would be plus 2x plus 14, okay? Some of you, this is how you went, and this is how you answer the question, and then of course you would combine the like terms, solve from there. What we're working on today is we're going to be given this piece, and we're going to have to go backwards, back up to here. Okay, so let me show you. Here's our first example. First thing I want you to do on your notes would be to close the brackets around. Because if you remember what we're doing, our goal is to get brackets around it like this. Okay, so let's just start off with the brackets. All right, so if our goal is to get something like this, okay, we know we're going to have brackets set up. So we're going to set these up. So the question now is, what do these share in common? Well, this term here, this first term, they share an x. So if I factor out an x, I would get 2y plus 7. Okay, so everybody sees that. Now, what does the second piece hold together that's the same? This one here, the only thing they share in common is that it's a negative. And so what you want to do is factor out the negative, which is a -1. So if you factor that out, you get 2y plus 7. You kind of see where we're going here. Now, ladies and gentlemen, we have the back end piece. These are the same. If these are the same, then you would just write it down right here. And then what you do is you bring this piece here, bring this back over here, and you put this back together. So instead of seeing this, okay, where we went from here, we broke it into pieces, and we went from here, now we're going backwards. We're going to take the original, we're going to break it into pieces, and we're going to put it back together. So could I multiply this out and factor it again? Could I do the distribution method again, where I'd go x and then -1, I would drop this equation down into here, multiply it out, I would get this exact same thing. It's cyclical. I want to make sure it's cyclical. I want to make sure you guys understand we were going from one area to here, and you can keep going in a cycle. All right, it's learning how to figure out patterns and learning how to do these things. All right, so this next one here, here's another example right here. Let's factor these out. All right, you put the brackets around this one. You go brighter red than that. What do these share in common? Well, it's a 4 and an 8, so you can technically factor out a 4, and they both share an R. So what's left behind? Q, and this would be a 2, because 2 times 4 is 8. And then on this one, what can you factor out? Well, you can only really factor out a positive 3. And if you did that, you'd have Q plus 2. Same boat. Pieces together, they're the same. You drop it down to here. And then this would be come down here together, 4R plus 3. So there we go. We factored that one as well. Hopefully you guys understand the process that we're using. Okay, if you did not use the distribution method when we multiplied, that's okay. But just remember how we did it, okay, and know how we're going backwards. All right, what I want you guys to do is please take your time, work on these 3, and then I'll get back to you in a second. All right, so let's move along on this one really quick. First pieces are, when you factor these out, okay, would be these share in common an n. So it would be r plus 5. And this would be a negative 1. And then it would be r plus 5. They're the same thing. So it would be n minus 1. And then r plus 5. This one over here, if I did the same factoring setup, just like this, I would get 3p. So if I factored out a 3p, I got an n plus 5. So guess what we're going to probably have on the back end over here is an n plus 5. This is going to be a negative I can factor out. And I can also factor out a 4. And it would be n plus 5. So if you do that, 3p minus 4, n plus 5. Okay? On this factoring here, look at this one. Same setup. On this one, let me see my setup. If I factor these 2 things out, would be a w to the 3rd. What's left behind is a t minus 2. If I factored out a positive 10 here, I'm going to get a t, and then it'll be minus 2 again. So there is my equation. And then lastly, this one, the only problem I forgot to mention, so I apologize if you stared at this one and you thought, how do you do this? You actually have to rewrite this one. It's the only one. They should not be set up like this. The problem is I'm not sure if the homework has it set up incorrectly or not. If they do set it up incorrectly, then I apologize for having some difficult ones on there. But this one should be rewritten like this, so that way you guys could do the grouping. Because most of you, hopefully, if you looked at it, you thought, well, there's nothing that can be factored out of these 2 terms, and that would be correct. Because you can't factor a 4 out of here or a 2 out of either one of these. So they have to be rearranged to find the things that are similar. Okay, so in this case, it is the b squareds that are similar, so you move it. And then I just rewrote this to make your eyes aesthetically pleasing in a second. So they share a 4 and a b squared. If I factor that out, I get an a plus 3. And then if I factor out a 3 on this one, okay, or not a 3, sorry. If I factor out a 7 on this one, you would have a plus 3. Set it up, and there's your piece. Okay, so this is how you do the basic factoring. Okay, this is how you do the setup. If you have any questions on this, which I know most of you will, just continue to try to find the greatest common factor, rewrite it, and go from there. All right, now we're going to do what's called an additive inverse. So what we're doing is we're going to do the same setup. Okay, when you do the same setup right here, we're going to do the same amount of factoring. Okay, where they should already be set up for you. When we ask you to factor, most of the time they'll be set up appropriately. What do these 2 number-wise share in common? Well, it'd be the number 3. They also share an a. After that, ladies and gentlemen, it'd be 5, because 5 times 3 is 15. Minus, if we pull out a 3a, it'd just be b. Okay, and this one, what do they share in common? The only thing they share in common is the number 4. So it's a positive 4. And then it's going to be b minus 5. So are this and this the same thing? And the answer would be no, it is not. Okay, it is not the same thing. So an additive inverse means you have to multiply one of these equations by a -1. When you multiply it by a -1, what happens? It actually will switch the signs on everything. So we're going to multiply this, okay, by -1. We're going to do this by -1, -1, and -1. So when you rewrite these, okay, this here is still going to be 3a, 5 minus b, but now it's going to be -4. This is going to be b times a -1 is a negative b. Negative and a negative is a positive. Now, ladies and gentlemen, they match up. So your answer is going to be 3a minus 4, 5 minus b. Okay, so hopefully you guys understand that. What you're doing is multiplying the back end of this equation by a negative to switch the signs, because you can do that anytime you want, but you have to do it to this one section only. Okay, and so this is going to be the same setup. They share a 3, and they would share a b to the 4th. So if I did that, this would be 7 minus a, and then this would be, they share a 4 only, plus 4, and it would be a minus 7. So you can see it's the same setup. If you multiply this back half here by a -1, you would end up getting, it's multiplying, okay, you would end up getting 3b4, 7 minus a, and then this turns into a -4, and then these would switch, right, where it'd be 7 minus a, because positive 7, negative a setup, so your answer would be this. Any questions, ladies and gentlemen, please come ask me, okay? It's a fundamental thing as we move forward that you guys need to learn how to multiply by negatives sometimes as well. All right, so here's all the beautiful things as we would factor out, kind of how I told you guys before, okay? We're going to change the back end. They have the negative on this side. I didn't really like that, so I left it, and we went from there. What I want you guys to do now is please work on these equations, okay? Factor out, they're already grouped together, okay? Factor out what they share in common, and do the inverse property, and tell me what you get. All right, on this last one, ladies and gentlemen, hopefully you guys got it. Factor out a c. Okay, if you factored out a c, it would be 1 minus 2d. And on this one here, we could factor out a 4. If I factored out a 4, it would be 2d minus 1. Multiply this back half by a -1. Okay, and when you do that, you would end up with c, and then this is 1 minus 2d, but then this changes into -4, and that would be 1 minus 2d, because you're switching everything around. Now you can set it up. C minus 4 and 1 minus 2d. Okay, there's this side of the equation. This one here, you factor out the letter p, because that's the only thing they share in common. It would be 3 minus 2p. And if you factored out let's do the factor tree. I think you could factor out a 9 on that. So if you factored out a 9, it would be -2p plus 3. You can see the setups, how it works. Multiply this back equation here by -1 3 times, okay, or the whole thing by -1. Just not sure how to write that for you guys so that it makes sense. When you set it up now, p 3 minus 2p, this would then be a -9, and this would be 2p minus 3. So your setup at the end would be like that. Okay, so whoops, I wrote this wrong. Maybe 3, sorry. Let me rewrite that. All right, so ladies and gentlemen, that's it for this lesson. Okay, it's a complicated one. There's a lot of things going on with it. Please ensure that as we move forward, you guys can do this distribution by grouping. If you have any questions, please ask me. Homework is on ALEKS, okay? One thing as we move forward, we will be using this distribution method a little bit, But starting with lesson 8.6, we're going to be doing a different kind of factoring as well that's just as complicated, but hopefully it'll be easier for you guys to understand. If you have any questions, come see me. Good luck. Watch the video again if you need to. But otherwise, have a great day.